So this statement at the top, I put in an event is considered unusual if the chance of it happening or something more extreme is less than 5%. So this kind of comes from that 2 standard deviation rule that we talked about before. And the 2 standard deviation rule says that to look for outliers, and outliers are values that are unusual. And they could just be unusual, right? There's some people that are just really tall, and there's some people that are really short compared to everyone else, and it's obvious when you see them, like, oh, wow, they're shorter than I expect people to be. Average body temperatures, they say, is 98.6, but some people run hotter than that, and some people run slightly cooler. So it is unusual to find somebody with a body temperature of, say, 97 as their average temperature throughout the day, but it's possible, it happens. They're just rare individuals. And so there's this arbitrary mark we draw in the sand that says 5%. If someone is in like the upper 5% or the lower 5% of a population, then we say, that's rare. That doesn't happen often, okay? So I just have a little explanation of how we use that in probability situations. And this is going to come up again and again for the rest of the course. And this kind of tries to help see if you can apply that rule to a situation. So again, it relates to that two standard deviation rule. We'll talk about that more and more throughout the course. The situation in this case is, assume we have 12 jurors that are chosen from random from a population. Okay, so I've served on just about every jury there is in this region. And like municipal court, I've served on twice. It's supposed to be a random selection based on your residency in a given area. We have a population here that 83% of the people in the area are Mexican Americans. And so below here, I build a table expressing some probabilities that should happen. So if I just randomly select 12 people, I would expect about 80% of them to be Mexican Americans, because that's the general population. Is it possible you get an unusual sample where most of them aren't Mexican American? Yeah, that can happen, but it doesn't happen often. And could you have a sample where they're all Mexican American? The answer is, yeah, that could happen too. Is it usual to happen? So this is a table here I built for you that has the probabilities. So X in this case is the number out of 12 who are Mexican American. So notice the highest probability ends up being what? 10. Yeah, 29.6%. And just to kind of confirm that, if we take 12 and we take 83% of that, so 0.83 times 12, that gives us 9.96, which is about 10. So this says, on average, you should expect about 10 out of every 12 people you randomly select to be Mexican American, if the population is 83% of that. All right. And so then what we're going to do is we're going to apply this, this rule here. And I just want to sketch this idea out on a piece of paper to help better understand what the heck that rule means. So this is the unusual event rule. And the unusual event rule, the cutoff is 5% unless somebody says there should be a different cutoff. And it says something like, let me see a different way to word it. Okay, so something is, let's say, unusually, I'm going to break it down into a couple of cases, unusually high if the chance of it happening or something higher is less than 5%. So drawing kind of a sketch of that. Suppose I have a histogram. I'm just going to draw it kind of smoothed out, and let's say it's roughly symmetric. So imagine this is just a bunch of vertical columns like a histogram, but I just smooth the curve through it. So the mean would be somewhere in the middle usually, right? And so what I'm looking at is something happened out here, okay? So somebody's value was high. That value is said to be unusually high if the chance of it happening or any number out here, so if I get X or any value greater than X, if this probability is less than 5%, then we say this is unusual. And it goes the other way too, so I'm just going to state this for unusually low. So something is unusually low if the chance of it happening or something lower is less than 5%. So low and lower. Let's erase this part of the graph, because now we're looking at the other end. So if we find somebody has a measurement or something has a measurement way over here out to the left, and we look at what's the probability of that happening or something less than X. So less than, if this probability over here is less than 5%, the probability of all this stuff happening, if it's less than 5%, then we say, hey, this is unusually low, this value, whatever it is. Unusually low. So if we just look at body temperature for a minute, we expect 98.6 to be the usual body temperature. If somebody has a body temperature that's like 96, that's like way out in the fringes. The chance of that happening is probably less than 2%. Of the population might have a natural body temperature at 96. So probably something might be wrong. Similarly, if we went out the other way and we found somebody with a body temperature of like 101, that has like a 1% chance of somebody having that temperature or higher. And it's got to be or higher on that side or lower on that side. And we're going to use this idea more later. So this would be unusually high. And again, the test if something's unusually high or unusually low is if this group out here, and you can't measure the probability of a single number happening, it's got to be a group, if that probability is less than 5%. Now, sometimes the 5% is not a good idea. Like think about the doctor says, you know, you got this problem and I think we need to deal with it. Like, you know, you got a sore knee, so we're going to go in and operate on your knee. There's a 5% chance that you'll lose your leg. Would you do it? Or would you just deal with the pain, right? 5% chance of losing my leg, that's a little too high for me, right? So that cutoff, I want it to be lower if it's a life or death situation. I would want like a 1% chance of something unusual happening. So that the 5% cutoff is kind of an arbitrary line in the sand we draw. If it's a life-threatening situation, we would want to make it like 1% or less, okay? All right, so back to this problem here. So that's the long story. What's the probability of there being exactly 6 out of 12 jurors? That would just be this 0.073 there, or 0073. And notice there's nothing about a percent here, so I'm just typing the decimals as I see them. So there's, you know, less than 1% chance of finding 6 out of 12 jurors being Mexican American when the population has 83, if we're randomly selecting. And the random selection is important. The next one says find the probability of 6 or fewer. So that means I have to add up all of these numbers back there. And the 0 plus means it's not quite 0, but the decimals were so far out it was like hardly measurable. So I would just add the 0.0073 to the 0.013 to the 0.002, and what's that going to be? That's going to be 6, 7, 8. So that looks like 0.0088 for that one right there. And then it says, does 6 Mexican Americans among 12 jurors suggest the process discriminates against Mexican Americans, okay? So what's the probability of getting 6 or less? That's what the rare event rule asks about. It does not ask about exactly 6. It's got to look at the tail probability. And the tail probability is less than 1%, which should not happen. That should not happen by chance. So I would say there's something wrong with the selection process. So does this suggest the process discriminates? Yeah, it does, because that's too low to have happened naturally. Yeah, I got it right. Would it be unusual to find 12 jurors that are Mexican American? And the answer is, well, there's a 10% chance of that happening. No, that's not unusual. That happens naturally. All right, I think that's enough probability for today. I answered the questions in the chat. I'll be back tomorrow at this time if you have further questions. The ones before this are pretty much the hardest ones. Probably 17 might be the hardest because I don't give you any table. So it's like that problem I recorded in the beginning, number 16, but you're kind of on your own trying to do that. But it works exactly the same way. So like that spreadsheet I was playing with, where'd it go? Is a good way to try and bash out how to do these problems. And the videos go over how to build such a spreadsheet. But I'll do one of these again tomorrow, most likely.